Hi, I'm Paul from Test Data Services, and this is a management presentation of the tests that we've just gone through in the recent videos. So we've gone through the load test plan, the test artifacts, so scripts and scenarios and anything else involved in the test, and then the test report. All three of those video summaries were technical in nature with a technical audience in mind. This is for management. So I would normally do a slide deck, present to management in person previously, but now I will also send a video, or instead, if required, send a video. And this is a video summary. So this is what it looks like. Hi, I'm Paul from Test Data Services, and we've just completed the OpenID Connect tests, which included three main tests: a performance, load, and stress test with concurrency of 10, 100, and 1,000 requests. So actual concurrency, not users, even though we used users. Each of the tests ran for about 20 minutes, and we did 68, 637K, and finally in the last test in 20 minutes, 2.6 million transactions. So of the three tests, we generated request rates for OpenID Connect calls, which is the focus of the testing, of 41 per second for the 10 user performance test, 408 for the 100 user. Now note this is 10 times increase, which is great. That's what we want to see when we increase concurrency by 10. When we went to 1,000, we only got a fourfold increase of effective throughput, but we still did 1,600 transactions per second, which is pretty good. The performance up until we started to hit our capacity was very good, averaging well under 0.2 seconds per call. But even with a concurrency of 1,000, we only slowed down to about half a second, which is pretty good. Now, the best part, though, was that we got one error per 125,000 transactions, which is a really good error rate. What the performance looked like is shown in this graph. With a concurrency of 100, so before we hit any performance constraints, we can see that the performance here on a 2-second scale is well under a quarter of a second for all of the transactions. When we ran with a concurrency of 1,000, we started to increase up toward a half a second on the slowest call, which is the authorize. So the recommendations for this test cycle is to do nothing until you anticipate that the workload in the future is going to approach capacity. When that looks like it's going to happen, you should fire off a performance tuning cycle so that we can optimize things that can be easily optimized in code or database. And then we can do an increase in concurrent lambdas. We're on the default setting at the moment of 1,000. That can go to 2, 3, or even 4,000. So we could probably, without doing any tuning, double or even quadruple our capacity, but it would be better to tune first and then increase that concurrent lambda capacity. So the bottom line from the business perspective is the OpenID Connect platform, as it stands, should be able to support 30 million active users with a rapid sign up of up to 250,000 new users in a peak hour. And the basis for that claim is that each user typically, or each active user, has between 2 and 3 refreshes per day. And what I've done in the math here is I've assumed 3 refreshes, which is quite a lot more than 2. And if each user does 3 refreshes a day, that means each refresh per hour equates to 8 active users. We've got in this test evidence that we can support over 1,000 or 1,050 refreshes per second. That's about 3.78 million token refreshes per hour. Multiply that by 8, you get about 30 million users. So that's the justification. So we can handle an increase in load increase in user base of 250,000 per hour and sustain 30 million of actual users. So in this test, we have done a test plan. There's a video summary attached if you want to go and review it with the actual document, a test artifact review with a video, a test report, which we've got a video review of, and we've got the recommendations to undertake tuning and retest well before expected load approaches 1,000 OpenID calls per second. It's been a pleasure doing this testing work, and I look forward to doing some more in the future. Thanks.